Hi everyone, and welcome back to Conquering Math, where it all adds up. Today we're going to be talking about scale drawings. You might be familiar with maps, blueprints, as two common examples of scale drawings, and so today we're going to look at how you can make them and what information you can get from them. So today's learning target is I can use a scale drawing to find the actual dimensions and areas of real-life objects. As we're talking about scale drawings, we're going to be leaning on what we've learned about proportions. So a scale drawing is just a proportional drawing of a real-life object. The measurements on a scale drawing are proportional to the real measurements. So the scale of the drawing is the ratio of the drawing's measurements to the real object's measurements. And you might be familiar with a map scale is a great example of these. And so for example, if I had a drawing, it might be 1 inches for every 5 feet of the actual object. So for this example, we need to find the actual length of the living room. In the drawing, the living room is 7.5 inches long, and the scale is 1 inch to 3 feet. There are many different ways to solve this. In this case, we'll use the length of the living room and the scale to set up a proportion and then solve that. So what we'll do is we will label the measurement of the actual living room in feet as x, and we'll set up the proportion 7.5 inches over x feet equals 1 inch over 3 feet. If you cross multiply, you'll find 7.5 times 3 equals x, which means that x is 22.5 feet. So the actual living room is 22.5 feet long. Now let's talk about scale factor. Scales for drawings or models can often be written without units, but this only works if the scale drawing and the real-life object have the same units, so you might have to change one or the other. This is called a scale factor, and we typically write it in fraction form. And it's written with the scale measurement in the numerator, and then the measurement of the real object would be in the denominator. For example, 1 inch to 5 inches would become 1/5. Example number 2. A scale model of the White House is 17.5 inches tall. The actual White House is 70 feet tall. Find the scale factor of the model. The first thing that we need to do is get the same units for both numbers, so we'll change the actual height of the White House from feet to inches by multiplying by 12, which gives us a total of 840 inches. Now we just write the scale as a fraction, and then we can simplify it. So this means we have 17.5 over 840, and this simplifies down to 1/48. If you're wondering how I did that, I divided 840 by 17.5 using a calculator. So this means that the scale factor of the model is 1/48. Now let's look at an application problem. The floor of this kitchen will be covered in tiles. Each tile is 1 square foot. Determine the number of tiles needed. So let's make a plan. First, we need to find the actual dimensions of the kitchen. Then we need to find the area. And then we need to find the number of tiles needed, which in this case will be a little easier because each tile is 1 square foot. Now there is one important note. Do not try to find the area of the drawing first and then use the scale to find the actual area. It doesn't quite work that way. So you need to find the dimensions first, and then once you find the real dimensions, you can find the real area. Okay, so let's find the actual dimensions first. This time, instead of setting up a proportion, I'll be solving using some unit conversions, which is another option. So we'll start with the length, which is 7 inches, and we'll multiply that by 3 feet per inch for a total of 21 feet. Then we'll look at the width. 3 inches times 3 feet per inch equals 9 feet. Now we're ready to find the area, so length times width. 21 feet times 9 feet equals 189 square feet. And since each tile is 1 square foot, 189 tiles are needed for the kitchen floor. Independent practice number 1. A scale drawing of the Apollo lunar module is shown. Find the actual height of the lunar module. Pause the video, work it out on your own, and unpause the video when you're ready. Okay, so what you should have done was use the scale to find the actual height based off of the height of the drawing. So this time I used a proportion, 4.6 inches over h feet equals 1 inch over 5 feet. If you cross multiply, you get 4.6 times 5 equals 1h. This means that h equals 23 feet. So the Apollo lunar module is 23 feet tall. Independent practice number 2. The blades of a ceiling fan are 1.5 feet long. The blades will be 3 inches long in a scale drawing for the manual. What scale factor should the company use? Pause the video, try it out, and unpause the video when you're ready. So the first thing we need to do is to get them to both have the same units. So we'll change 1.5 feet into inches by multiplying by 12, and 1.5 feet is 18 inches. Then we'll set it up as a fraction. So we have 3 inches, which is the scale drawing, over 18 inches, which is the real fan, and this simplifies down to 1/6. So the company should use a scale factor of 1/6. Independent practice number 3. A diagram of a reception hall is shown. What is the area of the actual dance floor? Pause the video, try this problem, and unpause it when you're ready. Okay, so remember that the first thing we need to do is to convert the scale measurements into the actual measurements. So the actual dimensions, we'll start with length. 10 inches times 2.5 feet per 1 inch equals 25 feet. Then for the width, 4 inches times 2.5 feet per inch equals 10 feet. Now we just need to find the area of the dance floor, so that's easy, that's length times width. So 25 feet times 10 feet equals 250 square feet. The area of the dance floor is 250 square feet. So today you learned to use a scale drawing to find the actual dimensions and areas of real-life objects. Remember that the scale of a drawing is the ratio of the drawing's measurements to the real object's measurements. The scale factor of a drawing is the scale expressed as a fraction with no units. Thanks for watching this episode of Conquering Math. You can subscribe by clicking the button below, and you'll get access to more videos as soon as they're posted. You can also head over to conqueringmath.com to find guided notes for this video and to check out all the materials that I have available. Thanks again for watching, and I'll see you next time.